What you are about to see is a demonstration of a trial between two blasters. One blaster is blasting with slag, which is presently the most common abrasive used.
The other is blasting with SpeedBlast, Australian garnet. Each blaster has a separate piece of steel plate which has heavy mill scale.
In this demonstration, each blaster has an area of about 25 square feet. Which abrasive is the best? We'll let you be the judge. With SpeedBlast Australian Garnet, it is easy to achieve Class SP5 for reasons we will explain later.
Notice the clean surface and how quickly the operator can move the nozzle. Notice the blaster on the right using the SpeedBlast Australian Garnet is actually overblasting quite a bit and could move considerably faster.
Again, the blaster on the left is blasting with slag.
And the blaster on the right is using SpeedBlast Australian Garnet.
As you can see from the start to finish of the speed trial, the slag blasted approximately an area of 3 by 4 feet, or 12 square feet.
And the garnet blasted an area of 6 by 4, or 24 square feet, twice as fast. So what does this difference mean on a tank job which has 20,000 square feet of blasting surface?
Using slag, it would take nearly 23 days, based on an expected 6 hours, that the nozzle is actually blasting per day.
It would take the SpeedBlast user just over 11 days, based on the same formula, 6 actual blasting hours per day.
Well, in just labor alone, let's say each blaster costs the company $75 an hour, times 10 hours a day, times 22 days. Labor costs for slag would cost at least $16,500.
Now, if we look at the labor cost for SpeedBlast, using the same $75 an hour, times 10 hours a day, times 11 days, labor costs would only be $8,250. That means there's an $8,000 savings in just labor alone for the company using SpeedBlast.
Now notice the very great contrast between the colors of the two surfaces.
On the right-hand side, you can see the clean SP5 white metal class of blast, which is produced by the SpeedBlast Australian Garnet.
On the left, you can see the slag-blasted surface. Notice how much darker the color is. You can also see the shadow where the grid lines were, even though the blaster was trying its best to get an SP5. So it's questionable whether or not the SP5 can even be achieved when using slag. Notice how clean and straight the garnet blasted surface is, very good for feathering, compared to the uneven, inconsistent edge of the slag blast. Look how clean the surface is compared to the slag. Now let's look at what is causing the difference in color between the two surfaces.
What you are seeing here is the surface of the slag blasted plate looking through an illuminated surface 5 times magnifier. The black particles are actually slag particles which have embedded on the surface while blasting. This is a close-up video of a blast nozzle blasting with slag. You can actually see the black slag particles penetrating onto the surface.
Here is a simple diagram which shows what happens when the slag particles hit the surface. A small piece of slag breaks off and embeds itself into the steel. Now, when we look at these slag particles through a powerful microscope, we can clearly see these embedded slag particles. There are thousands of these particles in every square foot, which you can see are scattered all over as we look closely at this 1/4-inch plate. Note the cleanliness of the garnet blasted surface. This is because the garnet particles bounce off the steel instead of impregnating the surface like slag. The impregnation of the slag into the steel now explains the stark color difference between the blasted surfaces. Now we look at what the impregnated slag does to adhesion.
This is a picture of the slag blasted surface put to the adhesion test and failed.
You can see that the dollies popped off the slag blasted surface in this test. We now test the SpeedBlast surface.
There is strong adhesion with SpeedBlast Australian garnet, where the glue holding the dolly failed long before the coating would ever come off the surface.